Now that we've got absolute values pegged down, let's go for squares.
Section B, squares and square roots.
In this section, we're going to take a look at the expansive world of roots. There are many different types of roots, but we're going to start with square ones and work our way up.
Remember when we see something like 9 squared or 7 squared, that means we multiply the base 2 times. So 9 squared equals 9 times 9, or 81. And 7 squared equals 7 times 7, or 49. Well, finding the square root is just like doing the opposite of finding the square. Check it out.
See how 9 squared equals 81? Well, that means the square root of 81 is 9. Same thing with 7. 7 squared equals 49. So the square root of 49 equals 7. The square root of a number is simply the original number we multiplied 2 times. We use this symbol here to mean square root. It's called the radical.
This just in, the radical means we take the square root of a number. The number underneath the radical is called the radicand, and the whole kit and caboodle is called the radical expression. Let's go now to Carrie Curtis live on MathCam for more. Carrie?
That's right, Ralph. And we've been out here all day asking people that one key question. What do you do with the radical once you've found the square root? Here's what they had to say.
When you find the square root, you just chuck it.
You heard it here first, folks. When you find the square root, you just chuck the radical. I'm Ralph Newsman. Good night.
So if we saw the number 25 under a radical, that means we want the square root of 25. Well, what number multiplied 2 times equals 25? The answer is 5, so 5 is the square root of 25. We express this by writing a plain 5 and getting rid of the radical.
Now in the math community, or in one of your books, you might see a formula with some letters in it to explain the square root. Let's see what it looks like so it won't catch you off guard.
If you come across this, the number c is the square root of a if c squared equals a. Don't worry, this is just the letter version of what we've been doing with numbers. See how it works if we substitute the number 36 for a? Now what number multiplied 2 times equals 36? We figure out that c equals 6, because we know that 6 times 6 equals 36.
Okay, now that we've got that down, in this jungle of roots, there's something else we've got to look out for. We know the square root of 36 is 6 because 6 times 6 equals 36. But negative 6 times negative 6 also equals 36 because 2 negatives multiplied together equal a positive. This means that negative 6 is also a square root of 36. Let's look at this in more detail.
So how do I know when to give the negative answer or the positive answer?
Well, there's just a little something you got to watch out for. You got to pay attention to the way things are written.
When we see a radical sign, just a plain old granola natural no frills radical sign, it means we're looking for the positive square root of that number. See here, the square root of 9 is 3. Easy, right?
Now, if we want the negative root of a number, we'll see it written like this, with the negative sign in front of the radical. Not under the radical, but in front of it. This means we want the negative square root of 9, which equals negative 3.
So when we've got that negative sign in front of our radical, that's when we want the negative root.
Now, so far, all the numbers we've been considering have not only been squares, but also perfect squares. A perfect square is a number that has an integer square root. For example, some of the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. They're perfect squares because their roots are integers.
The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The negative square root of 16 is negative 4.
Now, these are all integers or whole numbers, which when multiplied twice equal other whole numbers. They're not decimals or fractions. This is why they're considered perfect squares.
But in this imperfect world, it's also possible to have squares that aren't perfect.
Take the square root of 18, for example. 18 is not a perfect square because no integer times itself equals 18. So let's try something a little tricky here. We're going to break this thing down to try and find some factors of 18 that might actually be perfect squares. Our first step in this process is to think of some factors of 18.
How about 6 and 3?
Well, yes, these are factors, but neither of them are perfect squares, so that doesn't really help us. But look at the factors 9 times 2. We know that 9 is a perfect square that has a square root of 3, so this is good stuff. These are the factors we want to use. Now, instead of 18 under the radical, we can make it 9 times 2. Then we can take the square root of 9. Remember, we express this by taking the 3 out from under the radical sign, giving us something that looks like this. 3 times the square root of 2. Why can we do that? Well, since 9 is a perfect square, we can take the square root of that factor, which is 3, and bring it outside the radical. This is how we end up with 3 times the square root of 2.
Now, technically, we can find the square root of 2 by writing it as an ugly-looking decimal. But for right now, we're going to leave that 2 under the radical sign because it's not a perfect square. So our final answer would be 3 times the square root of 2.
Now, just like we wouldn't win a gold medal in the Great Pancake Bake-Off if we never practiced making pancakes, we've got to practice our skills with non-perfect squares to make sure we've got them down.